Hello everyone, welcome to lecture number 14, which we are going to talk about the shift registers. So at the beginning we are going to talk about the basics of the shift registers. Then we are going to move to the types of the shift registers, as we've got four different types. They are serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So we are going to talk about those four types of the shift registers. So we can say that a register or a shift register is a digital circuit which has two main functions, and those functions are data storage and data movement. That means the registers have the ability to store data, and even they are able to to move data from somewhere to somewhere else, or by some types like serially moving data or parallelly moving data. So the storage capacity of each register or each shift register is based on the total number of the flip-flops that are used inside that register. So as much as flip-flops we have, it means that shift register can retain or can store that amount of what is called bits, binary bits. So as we said, shift registers consist of an arrangement of flip-flops. That means we have some flip-flops which they are connected together in order to form up a flip-flop. So as their shift registers are made from the flip-flops, so we need to have a clock pulse in order to shift the data from somewhere to somewhere else. So in conclusion, you can say a register is used solely for storing and shifting data. That means each register must have that ability to store data and shift data as well. So this is a shift register, which is serial in, serial out shift register, which means data gets into the shift register serially and it gets out serially as well. So at any clock pulse or at any given time, only one bit can get into the shift register. That means we've got 4 bits shift register. This is a bit, another one, another one, another one. First, the data come to this bit, and those are going to be 0. Then the second bit is coming to this bit, and the previously stored data inside this bit is going to be shifted to that one. So here how it goes, how it works. Like this one, this is the same as the serial in, serial out shift register. Okay, as you can see here, we've got 4 bits serial in, serial out shift register. 1, 2, 3, 4. That means we've got 4 bits. So the data gets into this flip-flop and it gets out from that one. So it needs 4 clock pulses to store the 4 bits. For example, if you have those 4 bits, at the first clock, this 0 comes to this one. At the second one, this one comes to this one, and this 0, which was stored here, is going to be moved there. And then the third clock pulse, this one gets into the shift register, and in the last clock, which is the 4th one, this one gets into the shift register. In the next slide, we will have another example that shows how the data is stored inside the shift register, so it's moved inside the shift register. But you can see here, each flip-flop, all of them are connected to the same clock, which is called a centralized clock pulse. So whenever this clock pulse is applied, it applied to all of the flip-flops inside that shift register. Look, in this example, show the states of 5 bits shift register. For the specified data input and clock waveform, the register is initially cleared. That means all of the flip-flops contain 0 before start working the shift register. That means they are all clear. Look, here 0, 0, 0, 0, 0. Q0, Q1, Q2, Q3, Q4. That means we've got 4 different flip-flops. Okay, whenever this clock pulse is applied, it's going to be applied to all the flip-flops. Okay, here the clock pulse is applied, it's a positive edge triggered. So if the data input, which is this one, in this case is 1, right? It is written 1. This is already been given. So it is 1. So in the first clock pulse, what happens? This one gets into the first flip-flop. Okay? This one gets to the first flip-flop. First, the Q0 is going to be 1. But what happens to the Q1, Q2? If you can see, the input of the flip-flop 1 is Q0. That means this one is going to be given to the input of the next flip-flop. So the 0 is going to go there. And this one is containing 0, it goes there. This one contains 0, goes there. And this one is 0, goes There. How about second clock pulse? This is the second clock pulse. So the data input, which is this one, is 1. Okay. So when the clock pulse is applied, this one data input gets to into that flip-flop. So this flip-flop is going to be 1. And this one, Q naught, is going to be the input of the next flip-flop, right? And it was 1 here. So this one is going to be shifted there. And how about the Q2, Q3, Q4? Because this one was 0 and this one was 0. Sorry, this one was 0 and this one was 0. All of them are going to be 0. In the third clock pulse, if you can see here, the data in, which is this one, is 0. So whenever this clock pulse is applied, the Q naught is going to be 0 because 0 is going to be given to the input. How about the Q1? The previous output of the Q naught was 1. So this one goes to the next one. And Q2, the Q1 was 1. So the Q1 is an input to the Q2. So this one is going to be 1. This one is going to be 0 because its previous input was, the flip-flop, it is first flip-flop, or the flip-flop next to it was 0. So this one is going to be 0 and this one is going to be 0 as well. And the same applies for the last clock pulses as well. You can see here in this clock pulse, the data in is 1. That means the first flip-flop is going to be 1. As you can see there. So, and what happens to the next one? The previous input of this flip-flop was 0. So this 0 is going to be shifted to the next one. As you can see there, it's going to be shifted to that one. This is how you can see how the flip-flops, how the shift registers are working. And this is going to be the last output, 0, 1, 0, 1, 1. So this is 0, 1, 0, 1, 1. Okay. So the next type, the second type, is serial in parallel out, which is very easy. Serial in parallel out. This data is going to be shifted or entered to the register serially, as we did before in the serial in, serial out shift register. However, when the all data are stored there, they are going to be available in each output line of the flip-flop. As you can see here, the circuit is the same instead, except we have these lines connected to the output. That means when the data input gets into the flip-flops, first this one and then shift to that one, shift to that one, shift to that one. By the last clock pulse, all of the outputs are going to be available. That means we enter the data bit by bit. However, we could get all of the data simultaneously. This example show the state of 4-bit register for the data input and clock waveform, which is this one and that one. This one or those are given. The register initially contains all ones. That means all of the outputs of each flip-flop inside that shift register are they are initially containing 1. So at the first clock pulse, what happens? This data in is connected to the first flip-flop, right? So what happens? This flip-flop is going to be 0. It was 1, but when the clock pulse is applied, the data input is 0, so this one is going to be 0. How about this one? This output is going to be given to this one, so it's going to be 1. This one is going to be given to that one, and this one is going to be given to that, so they are going to be 0. So how about the next clock pulse? The data in is 1, so the Q naught is going to be 1. How about the Q1? This input, the output of this flip-flop is going to be the input of this one. So this one was 0, so this one is going to be 0. And this one is going to be 1, and this one is going to be 1 as well. So this is going to be repeated as much as clock pulses and data inputs we have. Okay. Another type of the registers are parallel in serial out shift register. That means the data are going to be given to the shift register parallelly. All of the bits are going to be given to the shift register simultaneously, but the bits are going to be getting out from the shift register bit by bit. So we need to have only one clock pulse to get the data entered to the shift register, but we need to have 4 clock pulses in order to get those data out from the shift register. And inside this shift register, we have data in, which are 4 bits, and we've got one single line of the data output. And we have this pin, shift load. So whenever this pin is 0, that means we are loading the data to the shift register. The data is going to be entered to the shift register. But whenever it is 1, that means shift is activated, so the data is going to be shifted out from the shift register, and this is the clock pulse or the centralized clock pulse. You can see that here. This is the internal design of the parallel in serial out. As you can see here, the data are going to be entered parallelly. The D naught is going to be directly given to the what is called the first flip-flop. D1, D2, D3 are going to be getting into the flip-flop through those gates. But how? Whenever this pin is 0, that means we are loading, we are entering the data. So whenever this one is 0, this AND gate is activated, that one is activated, that one is activated, right? Because 0 and here becomes 1, so this one is going to be activated. So when those AND gates are going to be activated, G1, G2, G3, so the output of the AND gate is going to be the other input, because this side is 1, those sides are 1. So whenever one side of the AND gate is 1, the output is going to be assigned to the other side. So D3 comes here and the D3 gets here to the inputs of the next flip-flop, to the flip-flops. Okay, so D not here, D1 here, D2 here, D3 here. Okay, so the data is going to be stored. This is how we enter the data to the shift register. So, but we need to remember that the clock pulse must be applied, then the data is going to be stored. However, when this pin is 1, that means this line is deactivated and this line is activated. Okay, this G4, G5 and G6. So what happens? This Q0 comes here and the output is going to be Q0. Look, the Q0 is going to be the input of this flip-flop, and Q1 is coming here and it's going to be the output of the AND gate, and then it comes here and it goes to the next flip-flop. So again, for that one, this is the first clock pulse after the entering the data. And the second flip-flop, the same thing is going to be repeated. This one gets here, this one gets here and gets here, and from that one, this one is going to be the input of the AND gate and it goes to be the input of the next flip-flop. Look, we have this example. D naught is 1, 0, 1, 0. Okay, and we have shift flip, we have clock pulse, we've got data out. So we have how many clock pulses? 6 clock pulses. Okay, so first we need to have a look on the shift load bit. So in the first clock pulse, it is 0. That means we are loading the data, we are entering the data into the register. So what happens to the Q3? So we just taking the Q3 into account. The Q3 is going to be 0, right? Because D3 is connected to the Q3, so 0 is going to be stored there. So in the second flip-flop, we've got shift. So what happens? The data is going to be shifted. The Q3 is going to be 1. Why? Because the D2 is 1, so it's going to be shifted to the Q3. Okay? And D0 to D2 and D1 to D0 to D1. So in the next clock pulse, the Q3 is going to be 0. Why? Because this one goes to the Q3. It went there, and in this case, this one goes there. Okay, so this becomes 0. In the last one, this one is going to be the D3 after the third clock pulse. So this is the last data bit stored inside the Q3. And the last type of the shift registers is parallel in parallel out shift register, which is a straightforward and it's very easy. We need to have only one clock pulse to get the data in and to the data to be appeared in the output. So the data are going to be entered parallelly and they are going to be taken out parallelly, if you can see in this slide. Look, D0 to D1, D0 to first flip-flop, D1 to the second one, third one, fourth one. So if you can see that all the flip-flops are taking the output directly from the queues of each flip-flop, right? And there is no connection between each two flip-flops. So whenever this clock pulse is applied, this D0 gets here, this D1 gets here, this 2 gets here, this D3 gets here. So that means parallel data input and parallel data output.